So we're considering the graph below. Its equations in this form here, where there's an a value out in front that could be positive or negative. There's a squared, which we see here as a bouncer. And then there's another root that cuts straight through, and we can see that right there. The roots of the, well, first of all, what's the degree? Well, the fact that it's squared and then a single root here, it's a third degree polynomial. It bounces and then it goes straight through. And in fact, you can kind of think of it as the potential number of roots. If you did a fake line there, it's got a 1, 2, 3, 3 potential roots. We only see 2 actual roots because one of them is a double root. But the roots are at x equals -1 and x equals +2. We can see those here and here. The coordinates for the non-rooted point from a graph. Now, it says 1. We're given a couple to look at, and a third one down here. So I could identify -2, 1. I could identify 1, 1 if I wanted to. And there's also this guy 3 and -4. Those are any options that you have. Now when you see this equation here, and if we were to identify the square, which is the bouncer, that's going to be an x plus 1 that's squared. It's also going to be an x minus 2 that's not squared because it cuts straight through. The question then becomes, how do I find that value of a? And that's what we're asked for right here. To find the value of a, we need to plug in an x and a y value. Well, of these 3 options, I think there's one that's pretty easy compared to the others. I'm not going to plug in the easy one, but maybe you could. If you plugged in 1, 1 for x and y, you're in business. The reason I would plug in something different, I want to just show you, make sure that you're plugging them in the right place. This is x, this is y. So when we plug stuff in for y on this side here, I'm going to put the -4 in place of the y on that side of the equation. I'm going to say it's equal to a, and you might say, oh, but a is negative because I see it's going down. Well, that's true, and that's a good observation. That's something you want to think about at the end. When you're solving for a, you want to make sure that a is negative. Inside your parentheses, I know that's an x plus 1 squared, but if I'm using this point here, and I am because of that -4, then the x value I'm using is the 3. So I've got a 3 plus 1, and that quantity is squared. We'll get to that in a second. The last one is an x minus 2, and x again, we're using 3 twice. 3 minus 2, and that's not squared because it's to the first power. So we need to just simplify this now. X minus 2 is 1, that's nice. 3 plus 1 is 4, but 4 squared is 16, so I got a 16 here times a, and technically this whole side over here is 16 times 1 is 16, and 16 times a is 16a. So clean that up a little bit here. I've got -4 equals 16a. We're solving for a, so divide by 16. And shame on you if you say, oh, well, let's just make it easy. That's a -4 because 4 goes into 16. That may be true, but you need to reduce a fraction, not just divide out of convenience. So you reduce that fraction, small number on top, bigger number on the bottom. It should be a -1/4. That's your a value. We already talked about the fact that it's negative because the arrow is going down. So your equation is y equals -1/4, and then you've got x plus 1 squared, and then x minus 2.